Students, let's study the Chapter 4, Section 2, Amplifier Performance Indicators. In this chapter, we will learn amplifier input resistance, output resistance, and gain. Also, we should understand what is the distortion of the amplifier. As shown in the picture, we can put the amplifier circuit seen as a general four-port network. Then, there are input voltage and input current at the input, output voltage and output current at output. Their connection conforms to the general regulations of a four-terminal network. It can be seen that, for the amplifier circuit, its signal source can be represented by a voltage source composed of Vs and Rs, also can be represented by the current source composed of Is and Rs. Voltage and current sources can be based on the Thevenin's theory or Norton's theory to convert. For the output of the amplifier, generally at output of the amplifier, all have output load resistance RL. Let's introduce the input resistance, output resistance, and the gains. The figure shows in the general circuit model of a small signal amplifier, which shows the internal structure of the model. For input signal source, the amplifier can be regarded as its load, represented by the equivalent circuit Ri. Ri is defined as the ratio of input voltage to input current. The controlled source's VOT indicates that after removing the RL, that is, the output voltage of the amplifier after the load is opened, Ln means when the load's resistance is shorted, that is, when RL is equal to 0, the maximum current at this time. We call it load short circuit current. Use ION to express. Load short circuit current and load open circuit voltage both can be converted. Their conversion relationship is the load open circuit voltage VOT is equal to negative RO times the load short circuit current ION. Next, let's take a look at the techniques for obtaining the output resistance. First of all, we need to understand the output resistance is when facing the load resistance RL. At this time, the amplifier is equivalent to a signal source. Then, the output resistance RO at this time is equivalent to signal source internal resistance. So, how to find the output resistance RO at this time? Following the steps below. First, set the input signal source to 0. Specifically refers to shorting it to the input voltage source. If the signal source is a current source, treat this current source as an open circuit. After completing this step, connect the signal source to the output and measure or calculate current I. Under the action of the signal source V, then the ratio of voltage V to current I is the size of the output resistance. Next, we introduce the gain. Gain is an important performance index of the amplifier. It is also called magnification and is expressed by A. It is defined as the output of the amplifier, ratio to input. It is used to measure the amplifier's ability to amplify electrical signals. Since there are two types of power at the output, voltage and current, there are also two types of powers at the input, voltage and current, so that we can get four gains. If it is the ratio of output voltage to input voltage, we call it voltage gains and use AV to express. If it is the ratio of output voltage to input current, we call it transimpedance gain. If the output is current, inputs are voltage or current, we get the transconductance gain and current gain. Use input and output resistance. The four gains can be converted to each other. Now let's talk about two different situations, relatively special gains. The first is the gain when the load is open and shorted, when the output is voltage If you open the load, at this time, the gain reaches the maximum. We put the load resistance at this time equal to positive infinity. The gain when the load is open is called AVT. Let's see if the output is expressed in the form of a current source. If we regard the load resistance RL as a short circuit, this way the output current will reach maximum. We use the short circuit current gain AIN to express. Next, we look at source gain. Source gain is divided into voltage source gain. To further show, the size of the input signal source to the amplifier is intense. We can also introduce the concept of source gain. For example, when the input voltage source is excited, Vi is the partial pressure value of Vs on Ri. That is, Vi is the ratio of Vs multiplied by the resistance divider. Corresponding source voltage gain AVS is equal to the ratio of output voltage to input voltage source. After conversion, you can get the source voltage gain AVS is equal to AV times divider ratio of input resistance at input. Similarly, when the input signal source is the current source, we have to consider the current sharing ratio at the input. So, we can get source current gain AIS. It can be seen that AIS is equal to the current gain and multiplied by. The signal source at the input can be seen that the source current gain AIS is equal to the current gain, then multiplied by the split ratio between the amplifier and the signal source. From these two figures, we can effectively see that influence of signal source on amplifier excitation if for voltage gain. If the input resistance is large, then it can effectively convert the signal source Vs excitation to the amplifier. Conversely, if the input resistance is too small, then most of the Vs will be consumed on the internal resistance Rs, and only a small part can be added to the input of the amplifier. The same is true for the original current gain. We can see through such a diversion ratio. For current source as signal source, we want to make the input resistance Ri of the amplifier as small as possible. Only then can it be effective. Introduce current source into amplifier for excitation. Next, we briefly summarize these four gains. First, look at the picture. In the first picture, the input is the voltage source and the output is also the voltage. Obviously, it means voltage gain. For voltage gain, we hope that the larger the input resistance, the more ideal. We push it out and we can see that when the input signal is voltage, we require that the larger the input resistance, the more ideal. If the output is also voltage, then we have to ask. At this time, the output resistance RO as the internal resistance should be as small as possible. If the input is a current source, the input signal is current. Then, at this time, we hope that the smaller the input resistance Ri of amplifier, the better. Only the smaller the input resistance, in order to effectively obtain the current from the current source. If at the output of the amplifier, use current as output, we hope that the larger the output resistance RO, the better. Only in this way can more current be effectively drawn, output to load resistance Ri. Multi-stage amplifier. The concept of multi-stage amplifier is the amplifier which build up from multiple amplifiers. Then, for multi-stage amplifiers, its input resistance, output resistance, and gain. How should it be considered? Start with the concept of input resistance. We know that input resistance means treat the entire amplifier as the load of the signal source. Then it can be seen, input resistance of the entire multi-stage amplifier. It is equal to the input resistance of the first stage amplifier. and the output resistance is equal to the output resistance of the last amplifier. The gain AV sigma of the multi-stage amplifier is equal to the original ratio of the signal source voltage to the final output voltage. So, how should the gain of the multi-stage amplifier be calculated? If we consider the voltage source gain, we will convert the final output VO, compare with the original signal source Vs. We extend this proportional expression to expressions with multi-level gain. It can be seen that these two formulas are completely equivalent. But we can use the gain of the multi-stage amplifier expressed as the product of the gain of the multi-stage amplifier. If it is the original gain, we need to consider at the output signal source, voltage divider with input resistance. Okay, this is the end of this class. Please finish the test questions in this section according to what have you learned today.